Hello friends, welcome back once again in the video lecture series of digital electronics. Today I am going to teach you about adders. In the last lecture, I have already taught you about classification of logic circuit. In that, I have taught you that there are mainly two types of logic circuit. First is your combinational circuit and second one is your sequential circuit. Combinational circuits are the logic circuit which is having no memory at all, right? That means it is having no storage element. And sequential circuit is the logic circuit which is having memory element, right? So today adder, which is going to be discussed in this lecture, is the example of your combinational circuit. Basically, adder comes under your arithmetic and logic circuits, right? So there are so many arithmetic and logic circuits. Out of arithmetic logic circuits are adders, subtractors, comparators and PLD, right? But in this lecture I will focus on adder, and after that I will teach you subtractor. So let's start about adder. Basically adders are of two types, right? What do you mean by adder? First of all, we should discuss about what do you mean by adder. See, adder is a logical circuit, or adder is a combinational circuit which is used to design to add two bits, right? So for addition of two binary bits, we are requiring adders as a logic circuit. So adder is of two types. First is known as your half adder, that is known as your half adder, and second one is known as your full adder. Full adder, right? Half adder is also known as HA in short, right, by designing, right? And full adder is also known as FA, right? Okay, so half adder is used to add two bits. Suppose this is the first bit, this is the second bit, and if you want to add, so what is the logic circuit you have to require in addition of these two bits? Half adder will be required. And if you have to add more than two bits, then you have to have full adder. Say for example, more than two bits means what? This, or this. There are three bits, and suppose you want to add this number, so for this you have to require full adder. That means this first bit can be filled by 2 ways, 0 or 1, and the second bit is also filled in 2 ways, that is 0 or 1. So there are four possibilities of input binary bits that we can fill in these two ways, right? So to implement this in logic circuit, we need half adder. So what is the block diagram of half adder? Block diagram of half adder can be mentioned like this. This is a block diagram. After block diagram, we will learn about the circuit diagram of half adder. So this is your HA. We are having two inputs. Say, let's suppose X, let's suppose Y, right? Let's suppose here this may be your X, this may be your Y. So these are two inputs. X and Y are named as two inputs, right? These are two inputs. And what is my output? Output will be my, first will be your S and second will be your C, right? S means sum. S means sum. And C means carry, right? So before understanding about the concept of half adder or truth table of half adder, let's have a quick review on how binary addition is performed, right? So shall we remove this one, because after that we will discuss about, after completion of half adder I will discuss about full adder. So let's talk about binary addition between two bits. So how it can be possible? That is 0 plus 0 is equals to 0, right? 0 plus 1 is equals to 1. 1 plus 0 is equals to 1, and 1 plus 1 is equals to 0, with carry is equals to 1. So based on this concept, we will try to make the truth table of this half adder. Then we will design on the basis of truth table, we will come to understand about the logical diagram or logic diagram of your half adder. So based on this, how the truth table of half adder can be constructed? Let's see. So the truth table of half adder can be constructed in this way. That is, we may have only exactly two inputs will be there. Let's say first will be your x as per the block diagram, and second will be your y, right? Okay. So how many combinations I will be having as per these two inputs? I have already told you that we will be having four possibilities: 0 0, 0 1, 1 0, and 1 1. So on this basis, we are having two outputs. Say, right now I have told you, suppose this is your HA, that is half adder, this is your X, this is your Y, right? This is your S and this is your C. This is your S and this is your C. So let's check what is the status of S will be there and what will be the status of C. So in this case, we can design like this, we can calculate like this, that is 0 plus 0 is 0, 0 plus 0 is 0. And here there will be no carry at all, so we can write carry as 0, because while addition of 0 plus 0, we will be having some as 0, S will be 0, but we will be not having any carry. So instead, in terms of carry, in this state I can put 0. Okay, next, when 0 plus 1 will be added, the sum will be 1, and again there will be no carry. So no carry means what? The carry will be 0. If x will be 1 and y will be 0, then it will be your 1 plus 0 is 1, that is 1, and still I will not have any carry at all. Okay, so, and in the fourth case, what I am having 1 and 1. So in 1 and 1, 1 plus 1, what is the sum? Sum is 0 and with carry 1. That means sum will be 0 and carry will be 1. Say for example, 1 plus 1 is 2, and in binary addition 1 plus 1 is 2. 2 means what? 1 plus 1 is 0, with carry 1 is, that is 1 0, right? That is why here I have put that 1 plus 1 is sum will be your 0 and carry will be your 1. So this will be known as your sum and this will be known as your carry. That's why I have written here that this will be your sum, this will be your carry. So now just I am telling you to analyze these two outputs. Just analyze the output of S and just analyze the output of C. So I can say you, if you will be having a fundamental concept of logic circuit, then you can say that this is the output of this, S is the output of what? XOR. Isn't it? This is the output of XOR. What is the output of XORing two inputs? The same output you will get, that is 0 1 0. And similarly, if you see the output of C, what you will analyze, that this is the output of your X and Y, right? This will be the output of X and Y. So what deduction we can make from this truth table on the basis of binary addition, then we can deduce one thing, that S may be is equals to X or Y. First thing, and second thing, in terms of C, we can say this is your X into Y. So on the basis of this thing only, we can design the logic circuit diagram of your what? Half adder. So please note this truth table, right? And on this truth table, I will design your logic circuit. So what will be my logic circuit? The logic circuit will be my, in this way, that I will be having two inputs. That is, this will be your X, right? This will be your Y. And for some, I will be having X ORing Y. That means, simply I can say like this, this will be your XORing, this will be your XORing, right? And the output of this XORing will be your S, which is nothing but your X XORing Y. And by taking the same input like this I will just put one and this will be your C. That is, this is the sum, this is the carry. Carry will be nothing but your X into Y. X into Y. So, on the basis of the previous truth table, I have designed the logic circuit like this. I do hope that the concept of half adder will be clear to you.